Okay, not recorded. So I'll hand over the meeting to Jay. And yeah, Jay, you can start speaking about a little about you, and then maybe later on, like just take them through through what you have to say in these topics. Yes, Jay.
Cool. I'll start. I hope there are no spammers here who just stream
It's
videos.
okay. That we will handle. We will handle.
Okay, cool. I mean, I just
I
had
will pay attention to that.
there
Don't
was
worry,
there
Jay.
was some
Keep
kind of
keep your
I just doubted. I'm sorry about it.
keep your
About doubting it
keep
wrongly.
your eyes away from the chat. I will handle the chat.
Um,
I will mute myself and just go ahead and start.
okay, great. I'll share my screen. Can you see my screen?
Yes, sir.
I would request the person drawing on my screen to please don't not draw. Okay. Anyways, so yeah, I'm Jay. I would call myself a researcher. I'm currently interning at Learning and Intelligence Systems Lab at TU Berlin, Germany, and that's remote, where I'm working in robot motion planning. I will talk briefly about that sometime later when I talk about it. I can see someone drawing on my screen, and that's really...
Please turn off annotation, like otherwise people keep drawing. It's in more options, I think.
So, Dheeraj, can you do that for me, or do I need to do it? Visible annotation for others. And if I stop share and start sharing, that annotation will go, right?
Yes,
So
you're muted.
Find the stop annotation button today.
yep,
Usually
I
it's
did
right
find
there.
that. I did find that.
Yeah, I think you can hide annotation, I guess.
Yes, I did do that.
Yeah, you can disallow annotation
Hmm.
on your meeting.
Great. Cool. So my topic today is going to be abstractions in mathematics, and how I think of learning math as similar or analogous to learning to walk, or in fact learning any other skill. Right. So who am I? So I'm currently a researcher. I would call myself a researcher. I would like to call myself a researcher, a robotics researcher. I'm interning at Learning and Intelligence Systems at TU Berlin in Germany, which is currently remote. I work on robotics motion planning problem. I'll talk what I mean by that sometime in the future. And I said I'm interning there because I'm still a final year student at BITS, and I would be graduating soon, like in August. Uh, and I'm going to get my degrees as MSc Mathematics and B Mechanical Engineering. Uh, apart from that, apart from the academics, I like playing table tennis, and I've been cycling quite a lot recently. So the photo on the right is of my ride when I'd gone to Waspo from here. This is the Bina flyover. This like so like I've been cycling quite a lot, and I did 1,000 kilometers in March. Yeah. So in today's talk, I would want to talk about why I started liking mathematics, how I started liking mathematics, right from when Siddharaj would teach me when it was eighth and stuff, and why I later decided to do a degree in mathematics. So in seventh and eighth, I think Siddharaj was teaching me, and then in 9th, 10th was normal school. 11th, 12th was the JE coaching, the usual drill that people go through. And when I reached in my first year, I could get a good picture of what math looked like, what I had studied previously, and what it was to come. I mean, if I would do mathematics, what I would learn. And the structures in math was something that attracted me. So there are some things called abstractions in mathematics. So anything that you do, you abstract out things. You always don't have an example. You move out, you move away from an example and talk about things. Even simple arithmetic, like at the start, when you learn addition, you're like 2 apples plus 3 apples, then you count 1, 2, 3, 4, 5 apples. But then later you realize 2 plus 3 is always equal to 5, whether I have apples or oranges, and I can just forget that and just remember 2 plus 3 is 5. So this is an example of abstractions, and the structure of how these things are related to each other is something that I found interesting, and that's the reason I decided to do a degree in mathematics. So the agenda for today is to know what these abstractions are, why they are important, um, and what do they mean in general. So mathematicians define everything abstractly. That's the first point that I want to make, and we'll see that. Second is mathematicians have this tendency of generalizing. So mathematicians will just say, oh, let's talk about n dimensions, and not think about, oh, we live only in 3-dimensional space. Oh, let's talk about n dimensions, let's find theorems. So we can solve equations in 2 variables, or can we solve equations in n variables, something like that. And finally, I would like to tackle the question about how do you learn math, and share some of my experiences of what I do if I want to learn math. Right. So before I start, I would like to quote George Puya from one of the books that I read about him. He says that mathematics is not a spectator sport. To understand mathematics means that you need to be able to do mathematics, and that you need to have a pen and paper, or you need to try out some things. So what does it mean doing mathematics? In the first place, it means to be able to solve mathematical problems. So I urge you, if you're not having a book in hand right now, take a minute, go grab a book and a pen, because that's going to be very, very useful. I'm going to have a few questions, and it's going to be like a poll. So I want to try that out once before we jump to the examples. So I think Siddhara just shared this link. Could you guys please go to that link and check if it is working? You should see something like first question is coming. We have 7 questions here. So the first question is just trial. You can take your time and see. I mean, one person can give me if they can see.
We have to go on that link.
Yes. You might have to constantly toggle between my video and that link. I mean, whenever I'm asking a question, you would have to type the answer over there so that I know
Okay.
how many people have answered and what they've answered. And yeah, I mean, I've opened the first question, which is kind of an icebreaker. Just type in your favorite number. Cool, I've already got to the responses. There's one number which is a famous number.
Would you be revealing these answers to us?
Yes, definitely.
Some numbers are winning, huh?
Great. I think it is stabilized and I can now reveal the answers. Oh, there's still more entries coming.
I wrote two numbers. Is it okay?
I think you can put only one option.
Because my favorite numbers are two. Like we have two
Just
numbers.
choose one and put one there.
Is it okay? I put a 2-digit number.
Yeah, you can put any.
Okay, thank you.
Infinity, is that fine?
Put it.
I put it only one number now.
Great. So I hope everyone is familiar with how this thing is working. Should I reveal the numbers? Or I'll wait for
reveal it.
44?
Yes, sir, reveal it.
I think let's wait for 30 seconds and reveal it.
Reveal it.
I think people are still answering, right? There are 84 members, bro. Not a 20 ka class today. Yeah. Let's
Yes.
have some time. There is a prediction here by Avnish, who says that 7 will be the highest. Whatever.
So even I think 7 will be the highest.
Okay.
Yeah, this would be nice if you're putting the answer and then predicting what the answer is.
Nice.
One answer.
People are predicting already which will be the most likely number that is.
Okay, great. I'm revealing now.
Yeah, go ahead.
Things are stabilized. 7 is the highest.
Yes.
9 is the second highest. 2 is the third highest.
Sir, my favorite numbers were 1 and 2.
Cool. Great.
Not 1 and 2, 1 and 8. 2 is also like my it's like my second favorite number, 2.
Good to know. Cool. So now that you know how to answer questions, and you probably have a pen and paper in hand, I think we can start. So I'll start with a very simple problem, something that is picked up from your CBSE textbooks, which talks about finding age of a person, right? And the most simple question for today is 10 years from now, Neeta will be twice her current age. What is her current age? And it opens to answers, and you can answer now. Oh, many of them are getting a common answers. I believe that's correct. If you get it wrong the first time and you realize that it's wrong, you can always change the answer. There is an update answer.
So they're telling the answers in the chat.
Don't tell the answers in the chat.
The most would be 10.
You don't have to predict what the answer is going to be in the chat.
Sir, after this, should we fill that Google form that you sent? I didn't fill it.
Whenever you have time, whenever you're relaxing, you can fill it.
Okay, sir.
First priority is to do
Sir,
the
what
questions.
Google form? Sir, what Google form?
Arnav, focus on what Jay is saying right now. We'll come back. Yeah.
Cool. I think I'll wait for it to 25 and I'll reveal the answers. Cool, that's 25. And someone was cool. Great. So I think
Sir,
most of them got the answer about
Sir,
this.
someone told current age.
Yeah, that's funny. Whoever it is.
10 years. Like,
But cool. So do I need to solve it, or do you agree that it's 10?
We are
sir,
okay.
don't, you can solve, sir.
Yeah, I mean it's straightforward, right? She's 10 years old. 10 years from now, she's going to be 10 plus 10, and that's going to be 20, which is twice of what she is right now. The way you write it is you don't know what her age is. So let's say her age is something. Some give some letter. I would say it's A. 10 years from now, she's going to be whatever her age is, like the current age plus 10, and the question is saying that she is twice her current age. Like this age is exactly twice her current age, and then you put in A equal to 10 and it works.
Multiplied by 2.
Nishka, I didn't hear you. Okay, I think I should move ahead, right? I believe everyone
Yes.
must have gotten this answer.
Yes, sir.
The second question is a little harder. What a continuation of the first question. You have the same two people. And this Nita may not be the same Nita as the previous question because her age might be different. I don't know. So 5 years ago, Nita was thrice as old as Rita, someone else. And 10 years from now, she's going to be twice as old as her. What is Nita's current age? And oh, I need to fill that. So we can start answering questions, accepting questions. Cool. For those who have joined late, answers can be posted on the link here. Waiting for the options. You could speak out if you need some clarification on what I mean by the question.
I had a question.
Hmm.
5 years ago, so that is Nita's age 5 years ago, thrice as old as Rita. So Rita also 5 years ago, or Rita
Yes.
same like present age?
Both are 5 years ago. 5 years ago, their ratio was 3:1. 10 years from now, their ratio is 2:1.
Okay, thank you.
So,
There's a competition between the first two options. People are withdrawing. I think I'll wait for 1 more minute and reveal the answers. Okay.
There's one more competing answer. Huh?
Oh. It seems there are 2 answers. I don't know.
Sir, can you reveal?
I'll wait till 4:55.
Can you reveal it?
You wait a few more minutes, please.
Yes, I'm waiting.
So can you now relieve the
I know you understand, but I'll wait for. Yeah, I think it's 4:55. So I will reveal the answer. The answer is not important. I want to know how you solved it. That's what is more important, and that's what my lecture is focused on. How you write it. And yeah, a lot of people got the right answer actually. I don't know why these 20s are separated. There was this guy saying 50. This guy is saying 50. She's no was a nice answer. Another person saying 50. So yeah, people did get good answer. And by the way, just write 50 and not yours. And although
So what's the answer?
teachers tell you to write in yours.
Can you explain this?
Yes. So I'm getting the answer is not so important as understanding how it's done and getting the method of doing it, right? The abstraction is more important. So let's just read the first question, write it in an abstract way, read the second question, write it in an abstract way, and think about what it actually means, right? So 5 years ago, Nita was thrice as old as Rita. So in this case, we don't know what Rita's age is, nor do we know what Nita's age is, right? So let's just say their ages, I don't know. I'll follow the convention that whatever you don't know, you call it X. The other thing that you don't know, you call it Y. Right? So 5 years ago, if my age is, I don't know, 23, today, 5 years ago, it's going to be 23 minus 5. Right? So if Nita's age is X right now, 5 years ago, it was X minus 5. And 10 years from now, it's going to be X plus 10. Is this all right?
Can you repeat that? I
Yes.
couldn't hear you.
So whatever your age is today, 5 years ago, you were 5 years younger, right?
Yes, sir.
So your age would be your current age minus 5.
Yeah.
Perfect. So what I'm saying is Nita's age today is something. I don't know what that something is. I'll call it X. So 5 years ago, she was X minus 5. So whatever her age is minus 5. And 10 years from now, she's going to be whatever her age is plus 10. Because 10 years have passed. Make sense?
Sir, I think it's 1.
Huh?
Sir, I think 1 minus 5 equals to 4, and that 4 plus 10 equals to the 50.
Oh, so you're guessing the answer, right? We'll come to the answer. No need to hurry. right? So Rita's age was y minus 5, and 10 years down the line, it's going to be y plus 10. And now let's look at what the question says. It says that Nita was thrice as old as Rita. That means Rita's age, whatever that is, when I multiply that by 3, I'm going to get the number which is equal to Nita's age, right? Does this make sense?
Yes.
The first statement that I have over here. So first I wrote whatever their age was 5 years ago, current age minus 5, current age minus 5. And it says that Nita is thrice as old as Rita. So whatever Rita's age is, the younger one into 3 is going to be the age of the older. And 10 years from now, the second statement is 10 years from now, she's going to be twice as old. That means the younger one, if I multiply the age by 2, I'm going to get whatever Nita's age is.
Yes.
And this is an abstraction,
Okay.
right? Because here I don't care whether I'm talking about Nita or Rita, or if I'm talking about age. I'm just talking about x and y here, and these are some equations with two variables. Cool. And now I'm not assuming that you know how to solve it. You don't need to know how to solve it. Let's just look at this problem, right? And see how it looks like. So for some reason, which you will see soon, I will draw an axis, the graph where this is the x-axis, and please mute. Great, thanks. So for some reason, I'm just going to draw this axis. You don't need to know why. Let's just see how it works out. So if I put if Nita's age was 0, say for example, or let's say 5, if Nita was 5 years old, and then so if Nita was 5 years old, so like 5, 10, 15, 20, so something like that, and I have 5, 10, 15, 20, and so on. So if Nita was 5 years old, that is x is 5, then what is y? Can someone just shout out? I'm only looking at the first statement.
Is it 15?
It's 15 because 5 into 3 is 15.
Right. I'm saying what if x is 5, not x minus 5 is 5. So if x is 5, x minus 5 would be 0, right? So
Yes.
something into 0. So y would also need to be 5 in that case, isn't it?
Yes.
Can you repeat what you just said? I couldn't hear you.
I'm only looking at the first statement, right? And I'm putting at different values for Nita's age. So if
Answer.
if x is 5, then I put 5 here, so I get 5 minus 5 is something, 3 times y minus 5, and then that 5 minus 5 is 0. That means y has to be 5, so I get 5, 5. And let's put 10, right? Let's go linearly. So can someone who is not
Oob is playing back what you just said.
okay. What if Nita's age was 10? That means x was 10. What would you get? Someone just shout out.
5.
-5.
Huh?
5. Could you repeat your question?
Okay, or what if Nita's age was 10? What
10.
would Rita's age be? Or I think I'm getting a fraction here. Instead, let's put
So Nita's age is 5 and Rita's age is 10.
let's put Rita's age as 10 and tell me what Nita's age is. Nita is the elder one, right? How can her age be smaller than the younger one?
Current age is 20. So Rita's current age will be 20.
20. Amazing. In this case, right? So it's 3 times 5, which is 15, and then x is whatever. X minus 5 is this, x is 20. Perfect. So if this is 10, then this is 20, and so on. So but with 2 points, we don't know how it's going to come, and we don't have so much time to plot for every point. So there is something called as Desmos. I don't know if you know about it, wherein
Sir, I have used Desmos.
Yes, sir.
amazing.
Yes.
Yes, sir.
Amazing.
Yes, sir.
Great. So we're going to put this equation there and see what we get, and we'll make sense out of that equation. So we have x minus 5 is 3 times what Nita was 10 years back. So it is y minus 10, right? And you see, I get a straight line. So what does this mean? This means that, oh, sorry, 5, y minus 5. Cool. What this means is that if Nita is 20 years old, then
Rita's 10.
was 10 years old. And then over here, if one guy is 50, one girl is 50, the other girl is 20, and so on. So this is another point. If the elder one is 80, the younger one is 30, and so on. So if the age is something, so what I mean by here is the age of the older one and the age of the younger one, for which the second equation satisfies. Similarly, I write the second equation, which is 10 years now, 10 years from now, right? So does this make sense? So 10 years from now, Nita's age is going to be twice of Rita's age. So 10 years from now, and we discussed why this is true. Cool. So if Nita's age is 10 right now, 10 years from now, it's going to be twice. So it's going to be 15, comma, I guess, yeah, whatever. Right? So 10, 0, 10 years from now, it's going to be twice. So 10 years from now, it's going to be 20, 10. So it holds. So this expression is the second equation. This line is for the second condition that we have. The previous line is for the first condition that we have. And for this, we need the first condition to hold as well as second condition to hold. So which is that point that lies on both these lines?
So the 50 point.
This one, right?
Yes, sir.
50x and 25 point.
Fantastic. So now just by looking at this point, can you tell me how old is Nita and how old is Nita?
Nita is 50 years old and
And Rita is 20 years.
50 years old.
Rita is 20.
Rita is 20 years old and Nita is 50.
Fantastic. Cool. So what we see here is we converted this problem of whoever Nita and Rita are, I don't know who they are, into a problem of straight lines, and we solved it using straight lines, and that's what math does. You don't have to worry about. Just for fun, look at the next question and tell me if the answer is going to be any different from the answer in question 2.
So we are not able to see this the new question in the website.
I can't see your screen.
Exactly, sir.
We can't see your screen.
Yes, sir.
Can you please share your screen?
So your screen is not visible.
We can see.
The new question is not.
Yes, sir. This question is not yet up.
Can you see question, please?
So we can.
No,
So we
Sir,
can't.
it's like,
I can see it clearly.
sir, it's like
an item is below.
We can't see this
Question 3 is
question.
coming. So question 3 is coming as the same as question 2.
Yeah.
It hasn't come yet for me on the thing.
Yes.
I have not opened options for that. Can you see question 3
Can
now?
you show the question?
Yes. Question, sir, but
We can't see it on the website.
It's not on the website. I have not put it on the website.
so it's the same question in a different manner.
Exactly. Can anyone else notice that it's the same question with a different quoting on it?
Yes.
Yes, sir.
They realize
equation,
that
sir.
the equation is same.
exactly.
Yeah, the equation is the same.
yes, sir.
Exactly. So what I wanted to show here is when you write it in math form, right? In an abstract form, it doesn't matter whether you're talking about Nita or Ramu or Rita or Shamu, or whether you're talking about their age or you're talking about chocolates. The way to solve it is the same. Right? So once you learn how to solve linear equations, you can solve a series of problems which can be represented that way. You can find ages of people, you can find how many chocolates they were given. I don't know how useful it is, but you can. Right? Is my screen visible now, or is there some issue?
It's visible. It's
Yes,
visible.
yes.
So the screen is
So what I wanted to tell you here is when we write a problem as an equation or a set of equations, we do not need to worry about the problem. We can just solve it as a geometry problem, or there will be many other methods that you'll learn, but one way of solving is the geometry problem. A few questions, a few things that you can do here is, now we had this equation of two variables, right? What if you have three variables? Then how many equations would you need? What if there are four variables? Like instead of two people, there were three people. What if there were four people? What if there were 10 people? How many equations would you need? And to play with these things, you don't need to always formulate a problem. You can just take some 20x plus 15y plus 17z is 20, and 16x plus 14y plus, I don't know, 2z is 4, and then figure out what these x, y, z are. Or also the question to ask is, are two equations sufficient, or would I need more equations? I don't want the answers right now. You may know them, you may not know them. What I want you to do is go home and think about it. So for two equations, we required two, for two variables, when we didn't know x and y, we required two equations. If I don't know three people's ages, so I have x, y, and z, would I need three equations, or would I need four equations, or would I need five equations? How many equations would I need? These are the questions that you can ask yourself. Moving on to the next thing. The next is a puzzle that I want to ask you about the knight. So I believe everyone has seen chess. If they have not played it, at least seen chess.
Yes.
Yes, sir.
Yes, sir.
This is a problem to do with chess. So till now we were looking at problems which were to do with numbers, which we have been trained from our child that math is about numbers. But math need not always be about numbers. It's about probably solving questions, a good way of solving questions. So this problem, I just wanted to demonstrate that it is a math problem, but has no numbers at all. right? So it's like a chessboard, but what I have is instead a 3x3 chessboard.
Sir, actually, maths is not only related to numbers, it is also related to symbols and equations and science.
Right. Right. Great. So can you see my screen here?
Yes.
Sir.
Yes, sir.
Cool. So I have a smaller version of the chessboard. And to tell you how the knight moves, the knight would move something like one on the right and twice down. So it moves two
Can
times
you show the question?
one in the other direction. Can you not see my screen? It's also live on the
Or
website.
it goes like an L.
Yeah, it goes like an N. That's a good description. It goes like an N. So it goes something like it goes something like this. It's a different color. It goes something like this or like this. Okay. This guy can go something like this or like this. So I wanted to tell you, if I have to move from this configuration to the next, what is the minimum number of moves I need to make in order to do that?
2.
Don't shout out. You have the.
Sir, I was the first person to answer. I just got in like 3 seconds.
Amazing.
Actually easy.
Yes, sir, very easy.
Yeah.
Well, the answer has been told already.
Yeah.
I'll still wait for 25 people to get it right. And I'm hoping that 23 people have answered it right.
So the satisfaction of the people that
By right, you mean majority of them getting the same answer.
Yeah, majority are getting the same answer. Okay, so 26 have gotten the same answer, and let's reveal. So great. In fact, 27 people got the answer is true.
So it's like go down and go up. So it's like go down and go up like that.
So
Yeah.
you first move to 1B and then move to 3C.
Yes.
Right?
Yes.
Great. Now let's scale up things a bit and go for a difficult question where I have another knight in that place.
Okay.
So now I have a red knight and a green knight, and I need to swap their positions. What is the minimum number of moves required?
So can both be on the same place?
No.
No.
You have to swap both of them.
Yep.
Do they both have to move like one after another? Is it compulsory that they have to move?
Sir, both are like both moves are count for the green and red.
Yeah. So if I move the red one down here, so if I move the red one down here, it's one move, and then I move the green one here, it's the next move. Then I move the red one here, it's the third move.
Okay. Okay.
So this is my first move, this is my second move, this is my third move.
Sir,
You can call me Jay.
Do both of them need to go alternatively or
No, not
one?
necessary. Not necessary. You can move red as many times as you want. You can move green as many times as you want.
Okay.
They just should not be on the same square at once. And if you are answering and you get something like 2 moves, then just write 2, not 2 space or 2 full stop or 2 moves. Just 2 would be better. Just write the number. Okay, I'll wait for 1 more minute before I can give it. See 2 competing answers. Okay.
Sir, first I get one answer, but then I realized that both were in the same place.
So you can change the answer.
That's why it's changed it.
Great.
Then they would be killing each other.
Okay. Okay, I think I will stop now.
It's quite a bit of competition.
1 minute, 1 minute, 1 minute. I just found it.
Can there be 2 answers, or do you think it's a glitch? Both the answers are same.
I think we can have more answers, but I think the least amount of moves can only be 1.
No, but what I'm saying is it's a glitch. Both of the 10 and 11, the answer is same.
Yes, sir, might be.
Might be.
If
It's
they,
possible that someone wrote the answer space bar
Then
and someone
we
wrote
leave
just
the
the
answer.
answer.
common thing is that they press enter to like and to like submit it, but the thing goes down.
Yeah.
Then we leave the answer.
So probably I have the same answers and written in 2 ways. Okay, let's check and review. There are different answers.
Yes, sir, they are different.
In fact, the winner is 4 and not 8.
Yes, yes.
Someone wrote like when someone blah blah blah. Something.
Okay, so
Sir, 4 1 by just 1. 4 1 by 1.
It can't be 8.
Sir, the answer is 8.
The minimum.
The answer is
has to be 4.
The answer is 8, sir, not 4
8.
because the
okay.
No, sir, the minimum has to be 4.
I will listen to both.
The minimum has to be 4.
Okay,
8.
I will listen to both.
4.
So who is the person who's saying 8? Or let's say who's the
Me.
person who's saying 4? Okay, yeah, 8. Tell me, how is it?
So first we are moving the red knight to 1B.
1B. Then?
And the green knight to 2A.
Okay.
Then we put the red knight to 3C. So we have figured out the red knight. And the green knight is still on 2A. So we are going to move it to 1C.
Okay.
From 1C, we are going to move it to 3B. I just lost the track, sorry.
So you are at 3B, then you move to 1A. Right, you were at 1C.
Yes.
You moved
From
here.
3B, we move to 1A. From 1A, we move to C2 and C2 to there.
To the final answer.
3A.
Perfect. Now the guy who said 4.
Yes.
Can you tell me your answer?
Okay. So first we move the red knight to 2b.
Yeah.
Then we move it to 3c. So we got the red knight's position.
Then you move it to.
How do you put it to 2b? The knight moves around.
Yeah, so
Yeah,
you can't do that.
Two knights cannot be on the same
Yeah.
square, right? Is there a solution with two knights not on the same square with 4 moves?
So I thought the answer was 4, but now I realize that the red knight cannot play twice. So that green and the red will be on the same spot once.
Right.
Yeah.
So that's where I went wrong.
Cool. So the best answer that we have gotten is 8. We still don't know if it is the minimum. Maybe it is, maybe not. I don't know. But I think it's going to be the minimum. So let's keep 8 for now and move to the next question. For this question, I'm going to stop at 5:30 sharp. I need to swap red and green again, but there's a problem. There's blue down there.
So your screen sharing stopped.
How's that?
It didn't. I can still see it. No, sir. You're sharing.
Oh yeah, now it came. It had gone for like some time.
Can we capture the knight?
No, you can't. See, if we capture it, it's going to move out of the table, right?
Yeah.
Jai, the smile is mysterious. It's not mysterious at all. Keep a straight face.
I'm not a good poker player.
Yeah, poker. We should also do poker math class.
Oh, there is a course on poker on MIT.
Don't leave the meeting.
So this was so hard.
Yes, sir.
Sir, without a blue one, it would have been easier.
So that one goes here, that one goes here. That one goes here. So 3 goes to 3. Red goes to B, 1B. Green goes to that B.
Yes, sir. Arnav.
Sir, can we move the blue knight also?
Yeah, of course, you can move the blue knight.
Okay, thank you.
Oh wait, you can move the blue knight.
You say we can or we can't.
You can move any knight.
Two.
Just that you can't kill anyone.
And you can move this to.
The hell your mic is on.
So we can also move the blue knight, sir.
It's actually hard to imagine which pawn is which horse is where.
So was that Pahel telling Pahel that mic is on?
Yeah, it was.
Or if you can't find an answer, you can just write and I can't find, sorry. I mean, don't write sorry, I can't find.
I give up.
Yeah, I give up. It's I mean, math, every problem may not have solutions, right? You don't know if it has a solution. Just try.
How many of you have lost some hair because you're scratching your head too much? I can virtually see people scratching their head. Okay. I think Jai reveal the answer.
Wait.
Sir, 2 minutes. 2 minutes. Wait, no. Sir, 2 minutes.
Oh, I can see.
No, so people can change their
background
answer
filter
also.
background
Yes.
filter क्या हुआ?
There is a majority.
Cool. I think I'll reveal and see what's the answer, and then let's discuss. Ha. Bored. 1,000,000. I give up. I don't know. You can't. Oh, who's this? Who's this? You said you can't.
So me, Avnish.
Oh,
So I
I'll
succeeded
give you a
up to
word.
certain,
I'll give you a virtual chocolate.
So what's
so
the
I
correct
succeeded up to a certain point. Then I was
Can
like,
you
okay,
explain
let's
this
just
question?
do it.
So what's the answer?
Yeah, what's the answer?
Let's figure out. Right. Instead of solving it this way, it's very hard to visualize how the night moves, and because night moves in a very weird manner.
Sir, I was moving the blue and keeping the red there. The blue can't move anywhere, so it was like confusing.
Right. So it is confusing, and it actually doesn't have an answer. You can't find a solution. There is no solution. There's no way you can move from that configuration.
So there's no answer to the question.
There's no answer to the question.
Wow.
But then how do mathematicians know that there is no answer? You just tried and you failed doesn't mean there is no answer.
So the max I got is that blue is in 1B.
Yes, same with me. I exchanged the red and green lines, but I couldn't get the blue back to C1.
Yes,
That's why you can't.
So you can't solve it, right?
So the blue can be in B1 but not in C1.
That's true. I think so. Yeah. Blue can be in B1 but not in C1. That's right. That's the only way possible that green and red are in the right configuration. But how do I know that? Right? So the way is like till now we solved two questions. I mean the age problem we got it into an abstraction. This we were trying to solve in the raw form. Can we write an abstraction to this? So what I do is I write something like this, right? So what I'm saying is all these points I'm representing as nodes here, and two nodes are adjacent if a knight can jump from one square to another. So a knight on 3A can jump to 1B and 2C. That means 3A can be connected to 1B and 2C. So I've tried representing the square on the left as an octagon on the right, where two nodes, like every node is a square, and I have connected by an edge if a knight can move, if a knight can jump from one position to another. Cool. I'll give you 1 minute to think why this is true. If you don't get anything, just ask. Convince yourself that the figure on the right and the figure on the left mean the same thing. So on the figure on the left, the knight can only move one step either to the right or to the left from wherever it is.
Sir, I see. Sir, I say that it can happen. on the knight, red color knight from 3A can go to B2. Sorry, B1.
Are you talking about the previous question? Are you talking about this question?
No, sir. I'm just talking about what is shown on the screen here.
Okay. Yeah, this can happen, right? We solved that. This was the first question.
Hello, sir. Can you hear me?
Yes.
What happened was that somehow my volume was muted, so I didn't know that you moved on to the next question. So can you tell what do we need to do right now here?
I have represented the square on the left as something like an octagon on the right. So what I'm claiming is something on the left, the thing on the left and the thing on the right are the same thing as far as this question is concerned.
Oh, okay.
Because see, from 3A, the knight can either go to 1B or it can go to 2C. So I've connected knight. So I've connected the point 3A to either 2C, to both 2C and 1B. So the knight can either go here or it can go here. What I'm saying is,
yes, I got it.
this happens for every other point. So you take a random point, 1C. From 1C, you can either go to 2A or 3B, no other place. So where is 1C? 1C is here. So you can either go to, what is this? 2B or, 3B or 2A. So 1B can either go to 3B or it can go to 2A. So I'm just saying that this is another simpler representation to this problem, because it was difficult to think like that, right?
Yes.
Is everyone convinced? Is there someone who is not convinced with this explanation? Does anyone have doubts why?
No, sir.
This? Cool. And so now the knight is here and I want the knight to be here, which is 3C. I want to go from 3A to 3C. So I just need to do 2 jumps and I'm there. Answer to the first question is 2. Simple. What about the second question? For the second question, I need the knight to be here, right? So from 3A, I want it to be at 3C. So I wanted to be here, and the green knight, I wanted to go from 3C to 3A. So I want the green knight to go from 3C to 3A. So how do I do that? I move the red knight first, once. Then I could move the green knight so that I keep it vacant. Then another red knight once, and now I'm free to go to this 3A, but I would need how many moves? 1, 2, 3, 4, 5. So it is basically 6 moves plus 2, which is 8 moves. Does it make sense?
Yes,
sir.
Perfect.
Yes, sir.
Sir, I have a doubt.
Isn't this more simple than imagining it on a chessboard?
Yes, like
Yes,
sir,
sir.
you need a full ground. Sir, you need a full ground in this sum. So it's like you need a full ground in this sum. Like you got each and every square except the middle, which is impossible.
Perfect. That's right.
So it's like we were scratching our heads so much, and we could just use this technique and just finish the thing in like 5 minutes.
Exactly. That's the beauty of choosing abstractions, right? I abstracted this problem as a graph, and I don't need to worry about if it is a knight or something else. What about the last question? Can you tell me if it is possible? Now you know you have a much simpler thing to deal with. Can you tell me if it is possible?
No, sir.
If it is not, why not?
Because the blue one is in between the red and green. So if you try to bring the green around, like what we did earlier, the blue will be in the way. And since it can't jump over 2 spaces, it can't get out of the in between red and green. It'll always be there in between red and green. So if you want to move blue back to 1C, you'll have to move green all the way back to 2A also. If you try and go in the front.
Yeah, cool. That's perfect. So if I'm moving, if I go along the right hand, I mean this way, then I'm always going to find red, green, blue. I can never interchange.
Sir, actually, you can do it, but there will be one problem. A blue can never go to where the same spot it has begun from.
Yeah, so you could have an answer like this. Blue is over here.
Yes,
At 1B.
because sir, first you have to take this 3A to 1B, then the 3C to 2A, and then the 1B to 3C, and after 3C. After that, if you wanted to get to 3A, then you first have to move from the blue from 1C to 3B, then 3B, then 1C from 2A, and then keep on doing the same process until B reaches 1B.
Right. So it's because you cannot jump over a square. I mean, because green cannot jump from here to here. It's not possible. See, so you were struggling to solve this problem very much, and then when you represent it in this abstract way, it's called a graph, by the way. You can read more about it. It seems obvious that, oh, it's not possible. Why am I even wasting time on that?
Right? But if you get some such questions, what do you write as the answer there?
It's not possible.
So it's impossible. That's
impossible.
What you write?
Yeah.
Okay.
Sir, first I thought that to keep some random answer.
Sir, if your knight is in the middle, there is no way it can move.
Yep.
But you can interchange green and red, but you cannot take blue anywhere. Because if you do the same process that you did with green and red, blue will come in the way of green and red and kill them both. So that's why blue is going to be stuck there on 1B.
That's right. That's right. Great. So getting back to my knight problem, the conclusion from this knight problem.
Excuse me, sir.
Yes.
So the blue one, what you can do is you can move it to 3B first and do the other process, and later you can move it to 1C. Like sir, over there when you move it to 2A to 1C, then you have to move it to 3B, right? The red one. So then you before that you can move the blue one to 1C, and then you can move it to 3B.
Could you come again?
But sir, if you can't keep the blue stuck because you will need to go on 1A. So you can also move the blue one, and then you can find.
Just think about it, and maybe you'll convince yourself that no matter how many times you move blue, you can never get it back to 1C. When
so look at it this way: for the answer to be correct, the blue has to come in between red and green, right?
Sir, I got it, but this might not work actually.
So
if it's stuck at 1B and it will but it might go to 3C and then 3C to 2A, 2A to 1C.
So if you're looking at it, look at it clockwise or anti-clockwise. The thing is, blue has to be on the in between red and green.
So sir,
if we can move two knights at the same time, then we can solve.
But you can't do that.
It will always
You're right. So
interfere in the red. So it will always interfere.
Yeah, so it will interfere in the red, right?
Yep, that's right. It will interfere with one of the things. So it will be solved. So look at it now. Initially, when you move in the clockwise direction, it's red, green, blue. But then finally, I want it to be green, red, blue. And no matter what I do, I can never get this configuration, because no matter what I do, whatever moves I do, I cannot jump over the knights. So I always maintain this RGB thing. So whether I move red this way or this way, it's always going to be a red, green, blue. Red is here, it doesn't matter.
The
blue
blue
or
horse
green
can actually come in between the red and green, but it can only come in the hexagon way. It cannot come on the chessboard.
It can also, of course, come on the chessboard. You can go home and try. You can get this configuration. Like, so from here, you can get this. This is possible. You can go home and try that.
So it will never end up in green, red, blue. It will always end up from red, green, blue to green, blue, red.
Yes, red, green, blue to green. Green, blue, red. Yeah, green, blue, red, or blue, red, green, or whatever. It's like cycle thing.
So how can I play blue, red, green?
I mean, whatever. Green, blue, red, green. It's a cycle, right? It depends on where you start. Anyways, it's a detail. Nothing to discuss about that. So the thing that I wanted to point out here is that a good abstraction helps us understand a problem in a much better and a simpler way. And you saw that in the chessboard problem. It was so hard to imagine where the knights were moving, and when you wrote it as an octagon, it was much simpler to imagine and say that, oh, it's not going to be possible. Now I just want to talk more about philosophy and things. And this is this quote by Richard Feynman. We don't have much time, so I'm not going to show his video, but there's a video that I have linked in this PPT. You can go home and watch that.
So you fill the form and we will post you all, keep you posted with all the resources that Jay has planned to, share with you guys. So if you have not filled the form, please fill the form. So you will get all the resources, right? So Jay, I think about the dimensions things also, maybe you can skip that for today, because I think that will require more sort of in-depth understanding.
Yes.
Also, I think this was a hit with a lot of students. Like, I've got some messages coming my way saying this was very interesting and all that. So you will have to come back.
So it's not important to cover everything in one.
Yeah, but you have to come back. So
okay.
So,
I don't mind.
I think you can stop. You can just discuss this slide, and maybe then we can call it a.
In that case, I will show Richard Feynman's video, right?
Yeah, just show that video, and then we can call it a.
Right.
Yeah.
So I like this video because Richard Feynman describes the difference between math and physics in a very, very nice way. So whatever we discussed today, that mathematicians don't care about what actually things are happening, and physicists, or every scientist cares about what they're working with. So a scientist counting apples would say 2 apples plus 3 apples is 5 apples. But a mathematician would just say 2 plus 3 is 5. It doesn't care whether they're apples or bananas or oranges. And Richard Feynman puts it in a very nice way in this video here. Let's just listen to that. And also there's this nice book by Richard Feynman. Surely you're joking, Mr. Feynman. You could read that if you wish.
The mathematicians only are dealing with the structure of the reasoning, and they do not really care about what they're talking. They don't even need to know what they're talking about, or as they themselves say, or whether what they say is true. Now I explain that. If you state the axioms, you say such and such is so, and such and such is so, and such is so, what then? Then the logic can be carried out without knowing what the such and such words mean. In other words, mathematicians prepare abstract reasoning that's ready to be used if you will only have a set of axioms about the real world. But the physicist has meaning to all the phrases. And there's a very important thing that a lot of people who study physics that come from mathematics don't appreciate. The physics is not mathematics, and mathematics is not physics. One helps the other. But you have to have some understanding of the connection of the words with the real world. And this is a problem which is not a problem of mathematics at all. Mathematicians also like to make their reasoning as general as possible. If you say, I have a three-dimensional space, ordinary space, I want to talk about ordinary space. You know, you're in it, and you measure distances, and there are three numbers you need to tell where something is. You go breadth, width, and height. Three-dimensional space, and you begin to ask them about theorems. Then they say, now look, if you had a space of n dimensions, then here are the theorems. Well, I say, yeah, but I only want the case 3. Well, substitute n equals 3. And then it turns out, that very many of the complicated theorems they have are much simpler because it happens to be a special case. Now, the physicist is always interested in a special case. He's never interested in the general case. He's talking about something. When you know what it is you're talking about, that these things are forces, and these are masses, and this is inertia, and this is so on, then you can use an awful lot of common sense, seat-of-the-pants feeling about the world. You've seen various things. You know more or less how the phenomenon is going to behave. Well, the poor mathematician, he translates it into equations, and the symbols don't mean anything to him, and he has no guide but precise mathematical rigor and care in the argument. The mathematical rigor of great precision is not very useful in the physics, nor is the modern attitude in mathematics to look at axioms. Now, mathematicians can do what they want to do. One should not criticize them because they are not slaves to physics. It is not necessary that just because this will be useful to you, they have to do it that way. They can do what they will. It's their own job. And if you want something else, then you work it out yourself.
So this was it about the video. So he described two things. One is mathematicians prepare abstract reasoning that's ready to be used without knowing what you're talking about. And the second thing is they try to make things as general as possible. It may not be very useful for physicists, but to talk about high dimensions is very useful when you come into robotics or you're into machine learning. I was supposed to talk about this, but because we have less time, I'm not going to talk about that. But whenever we have problems in robotics, we come up with problems of 7 dimensions, 10 dimensions, 15 dimensions. So this problem here, wherein the robot has to go from this configuration to reaching the ball there, is something that I work on. And that's a 7-dimensional problem. This case, wherein you do image identification and things, it's a very high dimensional problem. And in fact, this picture over here can be represented as something in 25 into 25, which is 625 dimensions. So it need not always be space or just 3-dimensional things. Whatever mathematicians do can have weird uses in whatever things. And you could read about these things here. I have linked some useful text there. So to wrap up the talk, I said that learning math is like learning to walk. And in fact, I would like to generalize that it's not just learning to walk, but learning any skill. And the parallels that I find between learning math and learning any skill is that it takes time. To walk, you didn't get it in your first try. Surely you didn't get it in your first try, at least I did. And the second thing is it can be used for multiple purposes. Like you don't know what you're going to use your skill of walking for. Or for example, you learn the skill of video editing. You might be making movies tomorrow, or I don't know, you might be making some promo video for Vidyavriksh. I don't know. So it could be used for multiple things. You need to participate in it. You can't just watch YouTube videos and say that, oh, I've learned math, or you can't just sit in a class and listen to what the prof is teaching you and say that, oh, I learned math. You need to practice. You need to work out things. You need to figure out. Like you need to ask questions. You need to be curious. Why? How does this work? What if I do this? What if I do that? Basically explore the software. So whenever you're learning how to do video editing, you just see, oh, what does this feature do? So similarly, you need to ask questions like, oh, what if I do this? What if I do that? And that way you learn better. Also, if you have a goal in mind, or if you have an example at the back of your mind, so while learning video editing, if you're doing it for something, then you learn it faster than you if you were just to explore what are the features in the software, right? If you're doing it for something, you will probably learn more features in a much faster way. So similarly, if you have something at the back of your mind while learning math, although it can be used for multiple things, if you have a problem or some curiosity back at the back of your mind, you learn things faster. So I mean, again, reiterating on that problem, you were never taught 2 plus 3 is 5. You had 2 apples plus 3 apples, and like 1, 2, 3, 4, 5 apples. So you took the example of apples for learning addition, and later you didn't require that example at all. You could just do it without that example. So these are the 4 things I think helps you be a good learner. So how do you learn math? I would say, if I have to say this in one word, it's curiosity. And I think I've summarized what to do in the last slide. And maybe you could read books on math. Maybe you could just look at the nature and ask questions. Need not learn math. I mean, you may not learn math in that sense, but it's good to be curious about it. You learn something. It's good to be curious about things. So for learning math specifically, don't read everything. You're reading something like quadratic equations or something like that. Maybe sometime later, the book will say something like, okay, you know how to solve linear equations. Now let's move on to quadratic equations. Stop there. Think, how can I use linear equations to solve quadratic equations? Is there a way to do that? Can I simplify a quadratic equation as a linear equation? Think about that. Wait for some time. Ponder on the thoughts, and ask yourself some questions. Rediscovering theory is the best way to learn anything. Same goes with that. I've linked a few of my favorite YouTube channels, YouTube math channels, which I'm going to share with you. And yeah, that's it. And I just thought of putting all the math courses that were there. This was before the math degree. So this was like till 12th, and this is after 12th. Like, this is what you learn while doing MSc Math. Although I don't think I've covered all the topics here, but these are mostly what they are.
So Jai, could you go back to that page, and maybe you could share the slideshow with them? Is that,
yes, definitely.
Share the whole slide thing with them. No, not the one with the resources.
This one?
Yeah. So yeah.
Sir, I think I know 3 of them.
Yeah, great. So the thing is, guys, yeah, I saw that overwhelming response by, like, these are not my students, Jay. These are like all the people coming from all over the train. I just pushed the message yesterday, right? Just imagine if we had done it like a couple of days before, we would have had like 200 people joining us. Although some of them fizzled out because it's a Saturday also, right? Where people have to go to other things, do other things, and kids are at the, like, the parents have to go out, so they move out. So can you stop the screen share so that we can, all of us, just like come together, and maybe all of you can switch on your cameras and we can take a screenshot for the sake of social media. I hope everybody has filled the form, whoever is present today.
No, sir, I am not.
Yes, sir.
Switch on your cameras, guys. Let's take a picture. And those who are like from our class, all Vidyavriksh guys, please show your t-shirts if you are wearing them.
Sir, I have not received my shirt yet.
Where is Joy? I can't see you. Stand.
How can you not see me?
No, you stand, I'm saying.
Oh.
So Joy is also our guy, right? Like, he'll be there whenever we, like, I'll ask him to come again to teach you dimensions, because to be frank, guys, like, one of the aspects of dimensions I learned yesterday while discussing with Jay, right? So I think, guys, can you switch on your cameras? We can take a picture, all of us. I'll just take a screenshot quickly. I take this, yes. Please, Vedant, boy.
Yes, I'm just getting my shot.
No, it's okay. It's okay. It's without the shirt is fine. But let's take a picture.
Sir, 1 minute.
Yeah, come fast. Tia, I want to see you there. Gaurav. बस दो ही लोग बचे हैं, जल्दी करो यार. Please fast. Gaurik, Selmar, Pehel. I'm taking a picture. It's halfway through. Yeah, you can do V's and whatever, like shout or whatever, smile, right? Aryan, watch here, like look here. Yes, I think this sums it up. And guys, yes, to tell you, like we meet every week. If like for math we meet twice, for others, for physics, chemistry, bio we meet on one day each, right? Every week. And if you're interested, let us know. Like, you know, my contact is here, and we'll bring in Jay again for sure. Like that, he has still not completed whatever he had intended to, right? And yeah, I can see someone writing in binary. Have a great what?
Sir, it is day.
It's a day.
Yes, sir.
And then
Sir.
it's a full stop.
Day exclamation mark.
Oh, is it an exclamation mark? Guy, don't tell me you can read things in binary. Like.
No, I can't.
You become so nerdy that you can read binary. Yeah, that's that's the like height of things, right? Like, yeah, Saria, tell me, what is it?
So will you be taking serendipity this year?
Isn't this serendipity to you? How about we take serendipity in this manner? Like twice a
That would be nice.
Yeah, so that's what it is. Like when I used to do serendipity classes, it was just me, no?
Yeah.
But now these are all the people that, you know, have grown up. Yeah, and they are in college right now. So they know the most advanced things that are happening there. And they are giving you a perspective. So this is the best way to have a serendipity, right?
Bye, sir. Thank you, sir.
And then next week we can discuss something around what Jay had spoken about today, right? And I will share with you all the resources, guys. And if you are maybe like all the other people who don't attend our classes, if you guys are interested, please do contact.
Bye, sir. Thank you,
This is
sir.
my number. It is there on that thing also. Yeah, you can just WhatsApp me and then we can speak. And these are all online classes. So wherever you are, it doesn't matter. Sai Pranav. Now Sai Pranav has started writing in a big binary. I don't know why did I teach you these things? Now they're
Your fault, son.
They're making me regret this. I just told them the ASCII system the other day. And now they are typing this in chats. I have to decode it before we see.
Yes, so I wasn't there for that class.
You know, you don't come for math this year, no? We did it in math.
Oh, okay.
Arnav,
Hi, sir.
tell your father to say hi because Jay's father.
Hi, sir.
Hi, good to see you here, and it is very nice. I enjoyed the talk as well.
Great.
Very
great.
nice.
So, by the way, Pramod Maurya sir has advised me in one of my projects that I have done during 4th year, 2nd sem.
Sir, you can introduce yourself to the kids as well.
My name is Pramod and I work at National Institute of Oceanography. I work in the field of marine robotics. and Jay did his internship with us, and he did a wonderful work in designing a mathematical algorithm to go around a coral reef colony. How would the robot go around the coral reef colony while maintaining a certain distance? So he was generating a path for that, and he did a mathematical algorithm which will generate a path by itself, and then he used something called vector fields such that the vehicle is guided to the path. So it was very nice working with him. We still have more to discuss on that problem, which is nice.
Nice.
So I get
Yes,
to
sir,
see
surely
that
we'll discuss.
all his knowledge from all the sources which he has got, he is disseminating with the other kids, so which is very nice. So
And sir, you are also welcome to, one day maybe speak to our kids. Like we can host you one day, just like how we have done it with Joy, so that students get a glimpse into what NIO does, and what's your role there, and how they can see this, look at it as a career option as well.
Okay, yeah, thank you. Yeah, we can plan one of the days. Thank you very
Thank
much.
you. Yeah, nice. Yes,
Thanks
guys,
a lot.
if you guys have any feedback, or if you liked it, just if you could, since we are recording the thing, if you could just say a couple of words to Jai directly, it would be nice. Please switch on your cameras when you do that, guys. Floor is
Sir?
open. Just raise your hand. Just raise your hand when you do that. If there are multiple, I'll just.
Sir, I know a number Phil, and me and my brother Avish like to do Khan Academy. My brother's favorite video game.
Okay.
Sir, I also do Khan Academy.
Nice, nice. No, what I'm saying is, if you have any questions for Jai, if you want to say anything to Jai, just directly. It's like you have been mostly passive, right? Some of you were loud. That was nice because it was an interactive.
Class, I liked it,
Okay.
especially the part that was when you had to see how to do it with the blue one. It was quite like that.
Yeah, it was an epiphany, like you could do it so easily just now, and suddenly now this guy is giving us a problem which is so difficult to do, right? And then math makes it so simple. Yes, Avnish, go ahead.
I wanted to say that today's session was really nice. I also liked the activities we did in the poll, and I like how it was explained. So it was really good.
Ajay, I tell you getting a compliment from Avnish is a big deal. Huh? It's a big deal. He gets, like, if I do something very very trivial, he gets very bored.
Okay, thanks, Avnish.
Huge thing. Yes,
In fact,
Vedant.
I've kept the poll open, and the question is, if what is a better topic? If you think that this topic was not good, I mean, for this talk, what would it be?
Sir, can I tell what I wrote?
Yeah. Sure.
Maths is a piece of cake when you understand.
Otherwise, what is it?
Okay. Thanks.
What is it otherwise? Mr. Sai, other Sai.
Yes, sir.
Yeah, what is it otherwise? It's a piece of cake when you understand, but what is it otherwise?
So, like, maths is the best subject.
Okay. Okay, cool.
Sir, in the chat box, I wrote something when you scroll up.
Okay. People are writing in binary. Oh, this class was very raised to 10 interesting.
So, not that one, sir. Yes, sir, that only.
Yeah. Raised to 10, no?
Yes, sir.
Okay, so yes, Vedant, go ahead.
Yes, sir. This class is very interesting. I love the questions that sir had given us.
Please call me Jai.
They don't listen, Jai. They don't listen.
Very weird. I call Siddharth.
I love the questions that Jay sir had given us, especially the chessboard ones, because they allowed us to solve puzzles in a creative way through playing chess.
You could try this book.
You could share the link with me. Like we'll create a document for that. I will start working on it right away, Jay. Please fill the form if you haven't, because we'll be sending it to everyone who has filled the form. Because otherwise I don't have any other data, right? Except if you're my student, you will get it directly. Vedant, yeah, so what was I saying just now? I forgot. I'm forgetful.
Sir, have your
coffee,
sir?
What is it?
Did you have your coffee today?
I did. I just had it before the class, like an hour before. Maybe I need another cup. Yeah.
Sir, are you sure?
Yeah.
Did you know what I wrote? Math is fun when you explode your head to do it.
Explode your head to do it.
Yeah, explode. But in the night puzzle, I had to explode my head.
Yeah. Yeah. So it's nice to sometimes have your head scratching, right? Yeah. So and Jay, I would want you to tell them that you call me Siddharaj. These people still they call me by sir, just like they do to you.
Sir, so as I told you that day, you asked us to call you Sid. So we have just replaced the D with an R. It's
Siddharaj. Sir, it's a pet name, right?
Okay. Sir is a pet name for them. Anyway, so guys, if you have anything else to say to Jay, the floor is open. Otherwise, in 5 minutes, I'm closing the talk. Thank you for participating, everyone, my students, as well as those who have joined us for the first time. I see that the numbers started dwindling because, of course, it's Saturday. People have been messaging me saying it was lovely, but we have to head out of the house and whatnot, right? So if you have a couple of words for Jay, then I'll keep the floor open. And if Jay has something else to say to them.
Great. I mean, it was fun. Thanks a lot for inviting.
You don't need an invitation. I will just drag you here. Okay.
I mean, thanks a lot for
I'll drag you here.
Having me.
Now that I know you can teach, I'm like, in some of the classes, I'll be like, okay, Jay, can you do this? And I'll relax.
I can say no.
Yeah. So yes.
Yeah, so it was fun. It was fun, especially because you guys were so active and replying, and saying so many things, which was nice.
Exactly right. So I think and pretty sure, like, so the best part about this is now that you have done this, I'll be calling all these other guys, your friends, all these Ravina, Rajdeep, Yash, all these people I'll be calling. Now I'll show, okay, this guy did it, now you do it. And these very people who are sitting as students, hopefully after 10 years, they will come and give a talk just like you did, right?
That's great.
Yeah.
That's how it should work.
Please, let's form a group of Vidyavriksh kids. And even after you're not kids, we are all kids, right, in the end. Yeah, so that's about it. I think, thank you very much for joining us.
Cool.
Yeah, and hopefully if you fill the form, we'll send you the resource booklet or whatever, like it will be a PDF. Yeah, just give me one day at least to do it. On Monday, it will be in your inbox and WhatsApp. Yeah. Yes, Aryan, good to meet you too. Okay, those who are still here, can you introduce yourself? Riya and Arav, Pehel. Introduce us, no? You?
Me?
No, the other Pehel.
Okay, sir.
You are Tia, no? Riya and Arav, would you like to introduce?
Sir, I've already introduced.
Did you? Yes. Can you show me your face? Because I can't register names very fast. You have introduced. Aryan AK. Go ahead. Aryan boy, you there?
Hello, sir.
Yeah, show us your face and just tell us a little bit about yourself.
I'm Aryan Katur. I study in 7th standard. Now I'm promoted to 8th standard. I study in Sri Chaitanya Techno School, which is it gives me the training of IIT JEE.
Where is it? Hyderabad.
Yeah, from Hyderabad.
Okay. Nice. Pehel Agarwal.
Sir, actually today's class was good, interesting and exploring.
Thank you.
Pehel Agarwal.
Hello.
Yes.
My name is Pehal Agrawal. I'm in 7th standard right now. Just got promoted to 7th standard, and I study in Sharda Mandir School.
Oh, nice. So you know Tia as well.
Yeah, she's actually my friend.
Yeah. So two. Okay, Pehel friends. Okay. Name friends. What about Gaurav Das? I guess I know the others. So Gaurav Das, Advita, Adishi. You can also. I know you, but you can also introduce. And Ankita. Yes, Gaurav.
Sir, I'm from Goa.
I think he's rapping.
I studied in School of Symbiosis,
Where
Siroda,
is that?
Goa.
Goa.
I just promoted to 8th standard.
Nice.
Also.
Nice. And what about
Hello,
other
sir.
side? Other side.
Hello, sir.
Yeah.
Yes, sir. I'm from Goa.
Yes. Good. 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 We'll catch up soon. Other side. Oh,
Sir,
what's
my
your
name-
name? What's your name? Sorry.
Sir, my name is Parjuri Adarsh Sai Narendra
I know
Babu.
that's a too big a name. What should I call you?
Adarsh.
Adarsh. Acha, wohi na.
Sir, I'm Adarsh. I am in 7th class. I just got promoted to 7th class. I study in Gitanjali Senior School.
Where is
in
that?
Begumpet.
That is in Hyderabad.
Yes, sir. Hyderabad Begumpet.
Acha, nice. What about Advita? Because these are the only.
Hello,
Yeah.
sir. I'm Advaita. I got promoted to 10th class.
Okay.
I study in Gitanjali Senior School.
Oh, same school.
It's in Begumpet.
Okay. Cool. Adishri. Adishri Kode. Hi,
Hello.
Adishri. Long. Actually, guys, Adishri is my student as well. When I used to take offline classes just before the pandemic. Yeah.
Hi
Adishri,
everyone.
go ahead.
Hi everyone. I'm Adishri and I'm a student of class 10 studying in the Rosary High School. And yes, about this session, it was too amazing. And I hope the tips shared would help me not only in my school maths, but also in my maths of life. So yeah, thank you. Thank you, sir.
Nice.
Call me Jay.
Advita, you know how it feels, no? Jai, no? Advita. Advita done, no? Yes, I think we are done. I
And yeah,
think, thank you
I
very
think
much.
also part of PCC, right?
What?
Additionally,
Yeah.
part of PCC also. Please don't call me sir if you come for cycling.
What is PCC?
Pandi Cycling Club.
Oh, you guys cycle together? Oh, nice. I was asking Jai, like, let's go cycling right now. After some time, I think it's too late, no, Jai?
It's too late. Tomorrow.
My cycle needs to be cleaned also. I've not ridden for a while. Yes, guys. So see you on Monday, my students. And
Sir,
Monday
I
was
fill
Monday.
the form.
Bye, sir.
Fill the form.
Yeah,
Bye,
fill the
both
form
of
if you haven't. Bye, guys. See you
Bye,
around.
sir.
Bye bye.
Bye, sir. Thank you, sir.
Bye, sir.
Thank you, Jai sir.
Bye.
Jai sir, very thank you.
Yes, sir.
Thank you,
to
Jai
Bharat
sir. Thank you, Bharat sir. Bye.
Bye, bye, bye. See you. See you.